Hello, everyone. Today, we'll explore the application of the Arc Commands, G02 and G03. Let's start with a simulation video to see how arc machining works. This is a handle part machining example. Notice the G02 and G03 commands used here. These are what we'll focus on today. Alright, let's dive into the G02 and G03 commands. There are two programming formats. The first one is for arcs less than 180 degrees. We could use the arc radius, r, to specify the center position in programming. The other is for arcs over 180 degrees. We could program the center position using I and K. We'll focus on the first method today. The G02 command moves clockwise around the center of the arc, while G03 command moves counterclockwise. So when do we use G02 command and G03 command? It all depends on the direction. Here's a diagram to determine direction. CNC lathes are two-axis machines with only X and Z axes. But let's imagine a virtual Y-axis using the right-hand rule. Visualize the machining plane. Look from the positive Y-axis toward the negative Y-axis. If the tool tip follows a clockwise arc in this view, use the G02 command. Conversely, counterclockwise motion means we should use G03 command. We also need to consider that there are two kinds of front tool rest and rear tool rest on CNC lathes. The diagrams show how direction is judged for front or rear tool posts. Most common CNC lathes use a front tool post. So, we actually view the motion from the negative Y-axis toward the positive Y-axis. But here's a note: regardless of tool post type, the same interpolation command applies to the same arc. If you're struggling to visualize, here's a simple trick. Look at the drawing. Identify convex or concave arcs. Convex arc uses G03. Concave arc uses G02. That's easy to identify. Let me explain the meaning of G02 and G03. X and Z are the absolute coordinates, referring to the final position of the arc. U and W are incremental values, meaning how much to move from the arc's start point. R is the arc radius. If the arcs are over 180 degrees, R takes the negative value. This R figure is common in milling. But for another point, you can't program full circles with the R value on a lathe. I and K represent the increment of the center of the circle on the X and Z axes with respect to the starting point of the arc. I is the radius. F represents the feed rate for circular interpolation. So with this in mind, let's look at the format of the arc instruction through small examples. As shown in the figure, we use the I, K, and R instructions to program separately. First, we analyze the dimensions in the drawing. The starting point of the arc is 20, 0. The end coordinates are 50, -10. The coordinates of the center of the circle are 20, 17 away from the start of the arc. The radius is 27. That is programmed as G02, X 50.0, Z, -10.0, I 20.0, K 17.0, F 0.1, with the absolute value of the I and K commands. Incremental programming is G02, U 30.0, W, -10.0, I 20.0, K 17.0, F 0.1. The R instruction programming format is G02, X 50.0, Z, -10.0, R 27.0, F 0.1. Incremental programming is G02, U30.0, W, -10.0, R, 27.0, F0.1. Through the above learning, we understand how to use G02 and G03 commands to program the Arc. Let's take a look at this graph. This graph has two arcs. After judging the first arc with G03, the second with G02. If you program in R, here is the programming. If you program in I and K, here is the programming. The focus of this lecture is on determining the direction, format, and meaning of the G02 and G03 commands, as well as how to use R, I, and K for circular programming. Well, have you got it?